In this video, I'm going to be demonstrating how to do a problem that's similar to one of the problems on the final exam. And this is problem 9.10 from Interactive Statistics. What makes a good teacher? A survey of 735 students from 9 business colleges randomly selected from the 1990-1991 American Association of Collegiate Schools of Business Handbook, that's a mouthful, in the United States was taken to determine the instructor behaviors that students believe are more likely to contribute to their academic success. A total of 735 undergraduate students enrolled in business classes was asked to rate various instructor classroom behaviors with respect to the importance to their academic success. One of the instructor behaviors was encourage team or group work. A total of 423 students rated this behavior as important to their academic success. Could the researchers conclude that more than 50% of such students feel this behavior is important? So the first thing we're asked to do is to state the appropriate hypotheses. And the approach I like to take to creating the statistical hypothesis is to first think about what I like to refer to as the researcher's hypothesis. What is it that we're trying to establish as being true? And in this case, it's that the true proportion of students who think that this behavior would be helpful is greater than 50%. So that researcher hypothesis is always what goes in the alternate hypothesis. And then the null hypothesis becomes all the other possibilities. And previously in other videos, I've also mentioned that it's also correct to write just an equal sign rather than an inequality in the null hypothesis. However, the null hypothesis should always have a statement of equality. So in other words, we should always have either a less than or equal to, an equal to, or a greater than or equal to in the null. And the alternate is always going to not have equality. And this is what we're trying to establish. Now for part B, we're asked to summarize the results in the form of a test statistic. This is one of the nice things about the test statistic is it takes the information and it puts it into a single number that we can interpret. And in this particular case, we would calculate what's referred to as the standardized sample population proportion, and that's another form of a z-score. Now, one of the things that I've been noticing on your homework is that a lot of you are not using the calculator for this computation. You're using the formula, which I'm writing down here. And I think it's good to know the formula, but it's not necessary to do to use this formula to calculate the z-score. I'm going to go ahead and write the formula down just for reference, but the calculator does this calculation for us automatically. And this is part of what is called the one prop or one proportion z-test, which would be the correct test for this particular situation. And you might recall that in order to use the z distribution is a normal distribution, and you might recall that there's a sample size requirement that goes along with using a normal distribution to model the sample proportion. But in this particular case, we have a plenty large sample size of 735, so it's not an issue. I'm going to go ahead and jump to part C, though, which is to calculate the p-value, because the calculator will automatically calculate both the p-value and the test statistic. And it does this for all of the tests that all the statistical tests that we can do on the calculator. And so let me go ahead and clear this out. We'll start from the very beginning. To find the tests, the built-in statistical test on the calculator, you press the stat key and then arrow over to tests. And the one we want is the one proportion z-test. So I'll select that. And we'll type in 0.5 for p sub 0. That's the hypothesized population proportion. Type in the number of students in this case that, 423 students said that they felt this characteristic was important. And then the sample size is 735. So we type these values in, and we need to select the greater than. And remember, with statistical hypothesis tests, there's three possible alternates. The not equal to, which is what we refer to sometimes as a two-tail test, less than, which would be a left-tail test, or greater than, which would be a right-tail test. In this case, our alternate is a greater than, so we're going to choose greater than. And then we just simply press calculate, and the calculator gives both the z-score and also the p-value. And the z-score is really a useful number. This number is about 4. And what this tells me is that the sample proportion was about 4 adjusted standard deviations or standard errors from the hypothesized proportion of 50%. And anytime you have a test statistic that's like bigger than 3, you've got statistically significant data. So in some ways, I don't really even have to worry about the p-value here too much because the z-score is so big. But most of the time we do focus on the p-value. One thing I want to point out, and again, I've seen this error on a number of homework assignments, and also I think I've seen this on some quizzes as well. This p-value is not 2.1183, etc. P-values are probabilities. They always have to be less than 1. So that should tip you off when you see some number here that's greater than 1. You should be thinking, there's something else going on. And what's going on is this little e. That little e is how the calculator writes scientific notation. And what it represents is times 10 to the power. So all of that information is contained in that little symbol, that small e. And so the p-value is really 2.118398, etc., times 10 to the negative fifth. So really the p-value here is about, and I don't need all those decimal places of accuracy, but it's about 0.00002. And that would be okay with me. That answer is fine. And notice I got to this answer by moving the decimal 1, 2, 3, 4, 5 places to the left. So since the exponent was a -5, the decimal goes to the left 5 places. And then up here, the answer up here would just be z is about 4.09. And that's fine. Just to use the calculator and write down the z-score rather than using the formula. And then part D, we're asked to state the decision. Well, we would be rejecting H naught here. We have a very small p-value. It's much less than the specified level of significance of 5%. That's alpha, by the way. Alpha is 5%, and our p-value is much smaller than that. So our decision would be to reject H naught. And we have statistically significant significant evidence that, and there's more than one way to say this, of course. So I'm I might write more if I had more, if I were answering this on an exam or something. But in the interest of keeping the video short, this is the basic idea. We've got statistically significant evidence the majority of students believe this behavior is important. Now I have a practice problem for you to do. I'd like you to pause the video and try this problem. And be sure to send me a message if you have any questions about this problem in Canvas. Send me a message in Canvas. I'm more than happy to answer all of your questions and any confusion. I'll be happy to write you further explanations or give a more detailed explanation or give you some hints or things like that. Or if you want to know what the correct answers are, you can ask me for those as well. So please send me a message with your questions, and I'll see you next time.